Okay. Seem to run right now. Seem to work. Hopefully. I don't know. It probably is fine, I'm sure. Mm. Okay, seem to have started. Hello? Okay, seem to have started. Hello? Yeah, it seems to work, but just delay. Okay, so that seems fine, I think. Maybe I should lower the frame count because I think I have too much FPS, but okay, I don't know. I don't know. I cannot do that right now because I would need to do that before. Well, shit. Okay, it's fine. So let's just start doing BLCM. I guess this world that is literally called BLCM is the world that we need. So the chat is on. Everything is neat. Scrap mechanic almost crashed. That's also pretty neat. So I did tweak the settings a bit so the stream might look bad. Simply because I did this. But let's see. Maybe it will look nice. Maybe it will not look like shit. I did sleep for some amount of time, so that's why the stream started at not 8 a.m. but instead in 11 a.m. Yeah, I just did sleep for a bit, and I do feel myself a bit better. At least I don't feel like a complete vegetable. So that's nice. That's better. For now I'll load. For now I'll wait till the scrapping getting loads, and I'll listen to myself speak on the stream to check out the. How do I sound? I sound pretty nice actually. What if I'll do that? I don't know. Not much happens really. So if I'll disable it, will anything happen? No, nothing seemed to really happen. Okay, I'm just gonna remove it then. Also I have added the noise reduction. So you should be able to hear me quite well now. Hopefully. I probably should also add a compressor. But okay. What is this? Okay, for now we'll sit without the compressor. I just really have to option it before the stream. Okay. I don't know how the quality looks. Okay, it looks pretty nice actually, wow. So I have to probably enable the audio from the game. Okay, it looks pretty nice. Or the main audio, I guess. So I have oh god, I forgot. The audio. Yep, I forgot to disable the sound from the stream. Okay, so this is my previous attempt at doing PLCM. This was supposed to be memory, but I forgot to do one small thing called different freaking inputs. So this is not a successful thing. Oh, actually, I don't have to completely redo it because we have yeah, I don't have to completely redo this thing because I have it saved. Let me disable Fant mod. I mean Fant the GUI because it probably messes the bitrate a bit. Okay, so now what we need to do is we need to because this is XOR memory. This is a pretty standard XOR memory. Instead that we have now pretty interesting design here. So we have 2 inputs and 2 outputs. But we have 1 memory bit, so that's needed for the memory to be able to input and output 2 memory cells at a time. If we will attempt to write at the same time, we'll have some issues. So I'll have to actually maybe just make a normal XOR memory, really, because I haven't thought about the actual design of the computer, because I do want to make a dual core or maybe even quad core. I don't think it will be possible to do it quad core though, because simply the amount of logic gates that will be used. So I'll make a standard XOR memory, well, kind of standard XOR memory, and we will, yes. So I'm just thinking how can I make a memory. So with a so what I want to do is I want to have a memory that doesn't require a lot of blocks and has a pretty fast read-write speed. Let's go with a bit of a different non-standard, for me, non-standard XOR memory. So I usually do another 2 additional blocks, so it's an input and an output. So I have literally 3 blocks per bit. But actually, this is some kind of music, I guess. So that's better than nothing. Oh, wait, I do have... Wait, let me... Actually, let's play some music from Scrap Mechanic. I do have... I did download the music from Scrap Mechanic. Can I actually just slap it right here? What is this? Oh, okay, no, that's not what I want to do. I want to add some kind of like sound. Oh, I can. Can I? Random. Let me find the radio. The big radio, I think it was called. And we will listen to Scrap Mechanic music in high quality. In high definition. High fidelity, yay. Where is the big radio? That's F. A, B. Or was it called differently? Not big radio, but somehow... No, it was called big radio. Good. And so, can I... I don't know if it will... Oh god, yeah, it does play. Jeez, and probably very loud. Jeez, and probably very loud. Actually, that's neat. Let me make it just a little bit more quiet. Let me make it just a little bit more quiet. Let me make it just a little bit more quiet. Not that quiet, probably. Yep, that's perfect. Yep, let's go with that. I don't actually hear music, so I'm sitting in complete silence myself. But I do have a third audio channel, so that's neat. Okay, so you're listening to Scrap Mechanics music, and it's called Big Radio. Because, yes. So what we're gonna do is we're gonna make an input and double output. Double output is needed for the reset part. Or no, this will be another input actually. Because we already have an output. So we can make double input. Yes. So if we could use the same portion right here to set and reset. Wait a minute. Can we actually... I'm not going to do 16-bit memory right now. Oh, and yeah, by the way, I will create a computer with not 12-bit memory, because 12 bits are... that's non-standard and that's simply pain to work with, so I'm not going to do that. Okay, let's actually try. So we have to send a signal to first reset, and then immediately after set. Well, those can be just sequentially added. I can just slap... Yeah, let's go with... I don't know. I don't think we need another fourth logic gate. I don't think it will be faster. I don't think it will improve anything. So yeah, let's just go with this. So 16 bits, and this is L2 memory. So for the... Wait, L2? Yeah, I'm just going to make a second core with a little bit of an offset. So that they wouldn't overlap and nothing bad would happen. Timing issues, that would be a disaster to deal with though. If I will still have one. Hopefully not. Hopefully I will not do... I mean, will not have some timing issues, because... No, that's not something I want. And so, I hope the music is not too loud, but no one... There is no one on the stream, so... Doesn't matter. Maybe, probably no one on the stream. I actually don't know. Maybe there's someone sitting and like, dude, the music's too loud. It's probably not too loud. It's probably not. Yeah, it's not too loud. Actually, I am much louder than the music. Let me make myself a little bit quieter, because I'm a little bit too loud. Here we go, -8 decibels. I think that will be better. Loud. Here we go, -8 decibels. I think that will be better. Yeah, that's better. So, yes. Good. So now what do we do is... I forgot to connect these. That's pretty neat. So I'm just going to connect this, the inputs and outputs. Everything seems fine. And then let's connect the enable part. I hope you don't hear my washing machine on the background, by the way. Because, yes, I do have a literal fucking washing machine in my room. That's pretty normal. No, it's not. But yeah, it's gonna be fine. Oh my god, that's not what I wanted to do. Right, so can I please wire it up properly? I mean, weld it. So I'm gonna save this as 1, so I wouldn't lose the one memory channel that I've made. Maybe I fuck up something. I just don't want to completely remake it. Okay. Maybe I should have... Actually, no, I cannot glitch weld this. Yeah, I cannot glitch weld this. Okay, so we have... How much memory do we need? Guess this is the amount that people will need. 784 logic gates. That's quite a lot, but this is literally the minimum amount we can do. Also, why does it seem that it's... I don't know why, but I feel like everything is not a perfect square, but a rectangle instead. I don't know why I have fucking paranoia like this. But okay. So we have inputs. Should I wire it up completely manually? I don't wanna. I don't feel like wiring up this stuff completely manually. We'll have to change them to OR gates manually though, so... that's neat. So... After the memory, we will probably start doing ALU. I'll have to do an adder. I don't want to do an adder. I really don't want to make an adder. That would be just not nice. Yeah, I don't know. Okay, so... Going to open Advanced Blueprint tool. And we're going to blueprint edit this stuff. So this is blueprint unnamed 1. I have a named 2 and named 3, named, I don't know, 0.1. Everyone named on for everyone. Okay, so logic gate to logic gate. I know that you don't see this, but there is nothing very interesting here, so I just not gonna bother even showing this. It's pretty simple stuff, so if you used the Advanced Blueprint tool, you already know how it works. So 256 connections made from green to orange. On one axis, of course. And then we have to go from orange to white. 256. Okay, everything is fine. I just fucked up and I saved the wrong button. I saved it as new accidentally. That's not good. Well, okay, it's fine. It will be fine. So here we go. As you can see, there is everything wired up. That's just some black magic. I could use the multi-connection tool. It would be... I still would have to go through each block, but I don't feel like connecting. It still would be... I'm sorry. It still would be pretty manual, so I don't wanna... Okay, now... What I'm going to do is I'm going to place this range of AND gates. Then I'm going to connect them like so. Yeah, this game, if you don't have a good depth perception, that's quite a pain, really. Okay. Okay, nice. Let's now connect this one to this one, 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 this, this, this. Yeah, I know this is just fun. That's very interesting to do on the stream. I mean, at least you can see that I'm actually doing something and not just completely doing nothing. Although if I'm doing nothing, then I mean I am doing something. So this something is nothing. That does make sense. Why wouldn't it? So this one will first again is reset, so I'm going to reset the spot. On the previous stream I made an ASCII table and it didn't turn out well, by the way. Oh. Yeah, it's fine, we can do that. Not that way. Fuck. Oops. Okay. So this is first, then goes this. By the way, it's fine if we all do like... I can literally just do that. And it will be fine. So it will work. We'll still connect this... everything. So don't worry if I'll accidentally press 2 times on the logic gate, it will not disconnect. That's not an... a connection tool from Scrap Mechanic. Okay. And what I hate right here is the fact that it's this part right here it's pushing out. This is not nice. I hate it. I like when everything is on the same level, but this part is not the same level. So that's not nice. Like, shit. How do I change it though? How do I make it nice? Well, let's actually test if this memory even works. It should be able to. And yes, it works. It just works. So yeah, it writes once here because there is nothing attached to this AND gate, so it just outputs 1. So that's correct. So that's neat. Now I mean, I can use a like. Okay, so what I can do is I can move this block forward and this block on top. I mean, shift it a bit. So I'm going to do that with all of these, and fuck, I'll have to. I'll have to make them OR gates again. It's important to not misclick here, because otherwise, for some reason, this moving thing, when it moves, it for some reason checks for the collision. Like if it's attached to the creation for some reason, like there is a check for that. That's maybe I hope the fan deleted this piece of shit. Like, because why would you need to check if it's attached to, like, why would you do physics? Because if, for example, I'll do that. So normally it wouldn't, if I'll just press 2 times, I mean if I'll press 1 time up, nothing will happen. It will just be levitating for some amount of time. In Fant's mod, it will fall. Like, that's extremely dumb, in my opinion. Why would you do that? I haven't checked the last version of Fant's mod is. Maybe he finally removed that stuff. Hopefully he did. I don't think he did though, because why would he? No, that's a pretty bad idea. It's annoying. Okay, now what I will do is I'll place some a decoder And I don't know. I don't know. Okay, it's fine. It doesn't matter if how fast it switch is. So like this. Wait, how do I actually connect these? Ah, dang it. Okay, let's place the logic gates right here for now. So we'll be able to connect those with multi-connect tool. I think I wired them correctly. Okay, so now it's time to do some magic and just connect those. So we are making a decoder finally. Such a fun process. Nope. Okay. Then this gates. Okay, neat. Then we will go with these in the connection for some. What the hell happened? These in the connection for some. What the hell happened? Okay, my connection just died for a second. Connection just had a mild stroke. That's nice to know. Mild stroke. That's nice to know. Also, is there no music? Or is it just too quiet? Also, is there no music? Or is it just too quiet? Yeah, I guess it was too quiet. Or is it just too quiet? Yeah, I guess it was too quiet. Okay, I guess it's fine. Okay, so have I connected? No, I haven't. So let's connect these. Okay, so that's interesting that my stream just crashed, but at least OBS said that it died. I don't know if it's what's the problem with that. What's up with that? Guess I'm overthinking it. It's fine, I'm sure it's fine that it just died. And I finished doing a decoder, finally. So now I will have to just move it forward and up. Because I can't do other way around. Because Fan created a nice mod. I mean, he did a mistake in the movement tool. Okay, so we have input, we have output, we have other input, but for address, and then we have another input, but for set. I mean, to write to memory. So that's it for the memory. I don't think we need more than 16. I don't think we need more than 4-bit address. So yeah, I guess it's fine. So right, that's neat. That's memory done. I will say it as mem 16 times 16. 16. This part 16 says that it has 16 bus, 16-bit bus, and it has 16 different numbers. That's it for the memory. I think it does mean like that. Yeah, 16. Yeah. As you can see, here is the timer memory, which has a lot of memory. I have a lot of memory. Yes, here we go. Wait, that's not even the fastest one. I have ones that have like. Let me delete this. I have ones that have. What? Oh. That have F somewhere. Okay, I guess I don't. I probably will utilize this. This is store memory. So yeah, I probably will use the timer memory. Oh, here we go. 4 kilobyte timer memory vanilla. Speed is 128 ticks to read write on average, and that's 4 megabytes of timer memory. Honestly, 3 seconds isn't that bad. It could have been much worse. So yes, that's just flex. Here's the 10-bit no, it's not 10-bit. It's 12-bit address. Actually, that's the amount of bits that I wanted to use in the dual-core computer in BLCM. But I'm not going to. I mean, I'm not going to use 12 bits. Oh, it literally says it right here, 12 bits. Yeah, I'm not going to use 12 bits of memory like this, because it's simply stupid. I'm going to use 16 bits still. Okay, so now, what I want to do is well, I don't know what I want to do. So we have done memory, and really I haven't finished doing the So I'm going to show you now the browser. Let me just browser. Okay. Yep. I don't know if this will work. Hopefully it will. Okay, that's perfect. Okay, I'm gonna give access to it. Okay. So now let's fix that, maybe? Okay, here we go. Here is the browser. 1920 by 1080, please. CSS. Okay, here we go. So right now you're seeing the logic. I mean, oh, I cannot move it. Shit, I guess I don't have. I cannot. Or, oh, I can. So right now you can see. Here is the data. Like here is the instruction set for the computer. So as you can see, here's some names of the instructions, and here's the schematics for this, for where the data goes. And really, I want to rename those. I mean, I want to maybe make those just move and not replace. I mean, not swap the numbers, but instead literally transfer from register A to register X, from register X to register Y, from register A to register Y. That hopefully makes sense. So we cannot transfer from register Y to register. Shit. Or maybe we do need to swap them. Okay, let's just swap them. Or we could write like to memory address. Swapping would be just... Okay, let's... Fuck it, let's... If the guy wants to write it... Yeah, let's do that. So again, from register A to transfer to register X and Y, so it's fine. Really, maybe we should transfer from register Y to register A then. It would make sense because A, X, X, Y, Y, A. I think it would just make some sense. Though then we will not be able to transfer to register Y from register A. And my washing machine is going wild. That's neat. I mean, we can transfer from register X to register Y. Okay. For now, let's leave it as is. I mean, it does say Tay. So yeah, let's leave it as is for now. So then we have subroutine calls. This is pretty standard. Jump and then jump condition. If register A equals to 0, maybe we'll add if register. So maybe we should add another one, but if the register A is equal to 0, if it's not equal to 0, jump C inverse. Jump CI. So jump condition, that's it. Jump condition inverse. So I think that makes sense. So this is unconditional jump, this is conditional jump, this is also conditional jump. That's it. Then there is bitwise operations. And then there is arithmetic. So actually I may want to... So here's the arithmetic, here's the bitwise operations. Yes, I forgot that I'm not showing my browser. Okay. Oh, hello the burger box, how's it going? Yes, I'm just showing the instruction set of my computer and... Yeah, you don't hear my washing machine that much, so it's fine. I do hear those. It's very loud. Right. So, as you can see, there is some interesting formatting right here. Like, I split the counting into 4 bits. I actually, why did I do it with 4 bits? I was supposed to split them with 5 bits because I'm going to use... Yes, this looks cool. Yes, it's pretty nice. So, why did I split it into 4? Okay, I guess we're using... Well, no, I want to have less... Although I will have... Okay. So I guess we're using 16 colors instead of 32 colors to encode the data. So how do I want to store? Let's go back to scrap mechanic. So how do I want to store the data? So we have a programming thing, a programming card, and we'll literally go through like this is 1, 2, no, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Not 16, it starts from 0, of course. But yeah, with that, we will be able to encode the data. So we'll be able to just split that. I mean, we can just encode that as a binary, and that will be our number. So, for example, I have number 9. What's the number 9? We will have to count, though. But you'll, at some point, I guess you'll just remember which one it is. So, this is 3, 4, 5, 6, 7, 8, 9. So this is 9, right? And 9 in binary is this. This is 9 in binary. And so with that, we have like this portion of the opcode. And then, for example, we have, for example, okay, let's, example. Let's go with a jump CI. So jump conditional, inverted, inverse, yes. It's encoded as 013. Or in binary it will look like this. And there is zeros. Of course there is fourth bit. Right, so this is how it looks. This is the opcode for jump CI. And so how we will encode it? Well, we have 13 and we have the 13 scholar. So this is 9, 10, 11, 12, 13. So my, I don't know if you hear me. My stream again died. I have no idea what's happening. Why am I dying? This is weird. This is weird. Okay, it's fine. So, yes, this is the way to encode this. So in the computer and on the program card, it will look like this. That's the whole opcode, just white and green. So that way, actually, the burger box, yes, I see. So that way, the burger box, I want also to encode the third dimension for the 3D printer, because we could just make it, because we have either no block or block in the, please don't break reality. Oh no. No, it's fine. Breaking reality is fine. So we can encode like third dimension using this way, because we have either block or no block. And so for the 3D printer we can just, well, 13. I guess we'll go from the bottom to top. So here's 13. And those blocks that are white, those are that activated. Those are the places where we need to place the blocks. So that way I can make actually printer print whole columns like that. So it will be able to just print this column pretty quickly. The yes dimension, yes, indeed. So that's my idea for how the program cards work and how the future 3D printer will work. That I might do today. So yes, that's my idea. So right, let's go back to figuring out the instruction set, I guess. So right, we have the what do we have? How will you decode the color to binary though? Oh, yeah, that's very simple. So to do that, we just, of course, as I said previously, yes, just hard-code it. So I'm going to use as much glitches as I want to, because glitches are nice, it's much simpler than them. But you can just make sensors, stack them like that. For example, I have for color white, so this is color white, gray, this gray, and black. And then we can just, the output will be just 4 bits. Well, here we really need just 2 bits, really. And we just literally hard-code it. So this is 0, we actually don't even need this then. Then 1, 2, and 3. That's it. And then, of course, we glitch weld it. Well, glitch weld, we can just do that. That's it. So, for example, oh, the color modes are changing. Okay, I guess I'll have to use not the this tool, because it for some reason resets every data that is inside of the sensor. I guess I'll have to use the advanced blueprint tool for that. But you get the idea. So if we paint it, it will be outputting, for example, gray. It will output 1, 2, 3. So that should be quite simple. So, now the browser. Now you can see why do I have this binary split right here. So it literally tells which color are we using from 0 to 15, and then it counts up right here. Because we're splitting the byte into 2 4 bits. I hope that made sense. Okay, so we have add and add carry. This is quite simple. Subtract and subtract carry, also simple, I hope. Because what we need to do, so when we add C is needed for the I guess the delay on the stream is a little bit big because I don't know what it does means. Okay, I mean, what's it referring to? But yeah, so add carry will be needed for adding, for example, 32-bit numbers. I'm not going to write 32-bit number right here, but as an example, let's go with, I don't know, 1 1 0 0. I don't know. And let's split it into 1 1 1 1. Yes, and let's add it to 0 0 1 1 0 0 0 1. So it will there will be carry, and so at the end we'll technically get zeros. But wait, no. For example, so this 4 bits, imagine that this is like first part. This is lower part of the of our register. I mean, this is like first 16 part of the number. So I guess, yeah, this will just add up to 0. So that's not a great example. It's fine. So first what we do is we do just a normal add to those 4 bits. So in the register it would be first first 16 bits of the number, and then the second 16 bits of the number, which will be 0 0 1 1. So we add this number 4 ones, and then 0 0 0 1. When we add those, we get carry 1, and we get a 0 0 0 0 as the in the register. Thank you for actually. Can I maybe get regular text as a format? Okay, great. So carry is 1, and 4 zeros is the output that we're getting in the register. And so now we perform an add carry. So this is add operation, add, and then we perform an add carry with the second part of the number, of the 32-bit number. Imagine that it's 32-bit number. So we do that. We add 0 0 1 1. I mean 1 1 0 0 and 0 0 1 1, and we get 1 1 1 1. And we also add the carry, as you can see from the diagram. We add carry, so we add 1, and we again get 0 0 0 0, and the carry flag is on. And that will be our result. 0 0 0 0. Like that. It's a 32-bit number. I hope that made sense. With subtraction, we subtract carry. I think I haven't when I was doing it. Well, yeah, let's try subtracting these two numbers. Let's actually go with If we'll subtract these two, it's fine. So when we're subtracting, we have to, I'll just invert this thing. Yes, so let's invert it. So we're adding this. And also we have to add carry because of how subtraction works. So we will get this in theory. So this is negative the number that it was previously. So it was 0011, 0001. That was the number previously. So we add these, and 4 ones plus 4 ones will be 1110. Right? Yeah, because we just shifted, we just multiplied by 2. So this is the first part, and this is subtraction, sub, and this is sub C. Right? Also, probably have to add some kind of remove carry or something operation, or we just do it automatically. Yeah, let's just clear the carry automatically each clock cycle. That will be, I guess, easier. So this is the first part. Let's add the second part. Second part will be 1 0 0 0. So yeah, subtraction is how I'm subtracting is I'm pretty much adding the inverse of the b plus 1. Inverse b plus 1. This is what I'm doing. So now, that's neat. And we do have a carry, and we subtract carry. Wait. Yes, we subtract carry. So we will get, previously we got this, and then we subtract carry, which was 1. This is carry, it was 1. And then we subtract it, and we get this number. And it should be correct. Carry, there is no carry. I'm not sure if it is correct. Let me actually test it in the almighty calculator. So we're going at the byte, I guess. So 11001111 minus 11001111. We're subtracting same numbers, and I didn't notice that. That's pretty hilarious. So this is already wrong. No, we're adding these. It's fine. Yes, I'm stupid. I forgot what we were doing. So yes, this is the inverse number. I forgot. So it's supposed to be this number. It was this number previously. I forgot. So yes, everything is fine. So let's subtract it as 1 1 0 0 0 1. And we will get a 9 and okay, that's so the result should have been this. I guess we're adding carry, not subtracting it, because the first part is correct, but the second part isn't. Why did I write that we subtracted then? We add carry. Yes, because we're adding carry because we're doing addition with inverse number. Here we go. Yeah, I did an oopsie. Where's music? Oh, the music died because in scrapping can. Oh shit. I'm gonna just play music on my computer, so it wouldn't matter. Let me open it. Because without music it kinda sounds very boring. And Scrap Mechanic radio music is very nice. It's calm. Let's open Big Radio. I hope it won't. Yes, perfect. So I'm going to listen to this nice music. So, rip the music, lol, yes. Okay, so, yes, we actually should. So first we got, if we add 1100 plus 1100, we get 1000, and we add carry and it will be this. And so we get this number because this part is high part of the register and this is low part of the register. Yes, that makes sense. Hopefully. I guess let's go to scrap mechanic. Where's scrap mechanic? Okay. Oh, you have music playing too. Let me just remove it. Yeah, I forgot that we're playing another music on the background here. So, how can I donate? BTC ADR? What? You cannot donate for now because I don't know, asking why would you want to donate? And what do you mean by BTC ADR? Yes, I can't hear the other music. Yes, I disabled it. What do you mean by BTC ADR? I don't like these acronyms. What BTC means? It's Bitcoin. Oh, Bitcoin costs 3 million rubles. Oh no. And stocks are... Well, 3 million rubles is quite a lot. So stocks will be fine. I mean that I can't hear the non-scrap mechanic music. Yes, I'm playing the music from a .wav file that I just extracted from the game, and I'm playing that because higher quality. Bitcoin address. Oh, the Bitcoin address. I don't have Bitcoin wallet. Yes, I don't have that one. That's very neat that I'm just dying for some reason. Maybe something is wrong with my stream, I don't know. Because that's very weird that that happens. Why does it happen though? That's the question. I don't know, let's go with quality maybe? That's weird, okay. Okay, so, well, it will be fine. That's right. Let me... Our connection is overloaded to something. I don't know, it's definitely not overloaded. Because I was... my previous stream was an actually 15 megabytes. No, megabits per second. And that's 15 megabits. Yes, 15 megabits per second. And right now it's 9 megabits per second, as the YouTube recommended, I think. So it's definitely not a problem. I just die. My stream just dies. I mean, I'm not skipping any frames. Everything looks good. I have a green thing. So yeah, that's pretty weird that I just die from time to time. But you know, it's fine. So, right. What do we do now? So I've made the memory. Do I do the registers now? I mean, I probably do have the registers already. But they're... Oh, wait, no, let's go with the instruction set. I wanted to figure it out. I still haven't added much. So, right. Instruction set. So I have add at C, sub C. It will be nice to have multiply and multiply C. And divide C. But the division, it's pain. So I have no clue how to make this with multiplication and division. How do I do carry? But I guess I'll reserve it right here, so I'm just gonna add mul and mul c. And we'll see what we'll have. And div c. Then goes the mod operation. For mod operation, we just have mod. I don't think we need mod c. It's the remainder of the division. Do we need mod c for the thing? Yes, we do. We will reserve it too. I don't know, maybe we'll add something right here. Let me open the chat actually. Nothing new. It's fine. So, right, we have division, multiplication. We might have division and multiplication. I can definitely do just normal multiplication. So data times reg A. And yes, the A register is still an accumulator, and I'm still performing all operations on the A register. I'm not. The register X and Y are just faster memory, I guess. That is literally just reserved. So yeah, data divided by reg A. Doesn't make much sense to do that in this order. I have to divide reg A by data. Let's swap those then. Yeah. Because I'm doing it a bit incorrectly. So data minus register add A plus carry. Then register A minus data into register A. Data plus reg. It doesn't matter which order here, but it just will look nicer. Data. Reg A. Data. Okay. So that should be fine. Now. I'm not going to even type here anything because I really am not sure how do I do that. Even in the operation. So I'm just gonna leave it as is. Mod is the percentage sign always, so I'm just going to do that. I haven't actually specified where the data goes right here. Into register A. And also skip here. So then goes the simple operations. Very simple arithmetic operations. And I guess I have to perform them on all three register increment, decrement for X, A, X, and Y registers. Yes. Let me move it right here. So what we're doing is I don't know, let's go with right here maybe. That will be very interesting to remember all of this. I guess I like to make it as like in the categories. I like to make categories, but I can't really categorize any of this. So I'm just gonna not even attempt, so okay. So inc X, inc Y, those are the register A, X, and Y. And then we're gonna decrement A, dec X, dec Y. So reg A minus 1, it's plus 1, not minus 1, plus 1, into reg A. And I'm just gonna do the same for register. X. Oh, I cannot do it. I cannot use control. Oh. Okay, register X minus 1 into register X, register Y minus 1 into register I. So this is simply needed because this increment and decrement operations are extremely quick. So they'll be much quicker to do than, for example, addition, subtraction stuff. The problem is there is... Yes, we need an operation that literally just accesses the carry, maybe. Let's do just that. Let's add an operation that just loads carry. I guess it will be here on top somewhere. And how do I call it? Load carry flag carry into reg A. No, into... Interesting. What's the point of registers X and Y if I'm not even using them for any arithmetic operations? I mean, how can I? I need like 2 arguments. Like on which... Very interesting, because right now what I have is I have add, and I'm just literally adding data. But it's like kinda nonsense. Like, what's the point of this if I'm not even... Like, I'm not using registers X and Y for anything. I really should have like add X and Y maybe, or A and X operations. Or literally just make it not, instead of data, use register X or some other register. Because otherwise it's kind of nonsense. I guess we use register X then? Because into register X we can like load something. Yeah, let's use register X then. Let's perform operations on register X. And A. A and X are the main registers then. So carry will go into register Y. I'm just thinking, will it be simple to... I have to create some kind of example program to just test all of the stuff. Because it's kind of complicated. So, carry, where do we move it? Maybe we should make, instead of this operation T, maybe we should replace it with TYA. So, transfer register Y to register A. Maybe that will make sense. I mean, is transferring A into Y is... Yeah, let's go with that. So let's make it TYA. Okay. Because that way we can, for example, we're... Well, I'm gonna write an example program. So let's load register A, some number, and for example, let's load 15. Load register X. Actually, we should add like big numbers then. Okay, let's go with this. 15 is the lower half of the 32-bit number. And let's store register A, SRA, into address 0. And this is the lower part. And then LRA. And let's go with, I don't know, number 4. Right? So to decode that, we need 4 times 16 plus 15. So the numbers will be 79, right? Actually, we can just look at this. Let me check. 79? Yeah, it's 4 and 15. Yeah, it's 79. So we have to multiply 4 by 15. No, 4, yes, 4 by 16. by 16 and add 15 to get the number. Yeah, that makes sense. So, I don't know. Yeah, you can see. Let me make it maybe zoom in to this part. Oh, it's on Russian. That's pretty nice. I didn't actually notice that. Well, it doesn't matter. You don't need it anyway. Everything is on English, mostly. So, okay. I'll RA and then store the higher half of the register into address 1. Then let's add another number, but now it will be number, I don't know, 9, 3. So it's equals to 3 times 16 plus 9. So 57 here. Let's actually do maths. So 4 times 16 plus 15. Perfect. So those are the numbers that we're gonna be adding. And this is a... I can have numbers so much bigger. This is... Okay, assuming our registers are for some reason 8 byte. A byte. I guess. So let's add those. So to add these, we will need to load the lower half. Data, yes. Okay, so load register A, address 0, add just a normal addition, and add it to 2. Like this. And then as store register A, because the data is being thrown back into that. Let's store it into, I guess, address 4. Okay, I'm gonna write some data. So this address memory. Maybe I should actually give the link to this thing. I'm gonna send this into chat. Though I probably should just save it into. Let me quickly add this link into the description so you could check out the stuff yourself if you want to. Let me change the video. It's not a video, but it's fine. Okay, so the description should be done. Okay, great. Hopefully. Yes, so you can now check out the actual link yourself. And we'll continue with trying to understand what we're gonna do. Oh, now I have an unknown chameleon and a no animal that I don't know translation for. Okay, so address 0 is 15, address 1 is 4, address 2 is 9, address 3 is 3. Makes sense. And address 4 will be lower half of the answer, so 5 will be higher part of the number. Okay, so we're loading number from address 0 and adding it to number into address 2 and storing into address 4. Makes sense. And yes, we don't actually... I wanted to make it automatic, right? I wanted to clear the carry automatically. Well, I can't. I shouldn't, because otherwise everything will mess up. So let's add another operation right here, and I'll call it clear carry flag. Carry, no, 0 goes into carry. I guess I have to make carry. I think, like, I'm thinking about multiplication. I have to make carry 16 bytes too. Oh, no, not 16 bytes. 16 bits. 16 bytes. That would be insane. 256 bits. But yeah. So now I have the operation CCF. I will not use it here, but it might be useful. So, next operation, load. Wait, I forgot how my own architecture works. I literally just typed add address to. Oh my god, I think I just started to forget how my own architecture works. So, I'm not using registers X and Y because I don't really need them that much. That's why I'm not using them. Well, I will still have them because it's useful to have those registers. It simply is much faster than accessing the memory. So I will have them. I do have operations text, txy and tyx, tya. So yeah, I'm going to add still data. So yes, the register A and will be still the main one, and X and Y will be registers that you can just completely ignore. Neat. Now, load register A with 0. Add the C number in address 3. Store register A into address 5. And so in theory, this program will add those numbers, right? So we're loading 15, storing into address 0, loading 4, storing into address 1. So this is, I'll mark this as a, probably will move it somewhere. Yeah, let's move it right here. Out of the screen, for example. Okay. Oh, there's something. I'm back. What program are you writing? I'm writing a program that will add two numbers, two 32-bit numbers in theory. I'm using numbers that can fit into a literal 4 bits though, because yeah, I forgot. But it will be easier to do some math. Okay. So here we go. So this is the lower part. I'm gonna mark this stuff, so it makes sense. So this is lower part of A, and this is high. Oh. Oh no, how do you type high? Oh my god. Forgot how to type high. High. Shit. This is awful. High. Oh my god, I forgot how to type high. H-I-G-H, fuck. Okay, that was the most complicated part of the stream so far. Remembering how to type the stuff. Okay, so this is a lower part of the A. I assume there will be user IO registers. Yes, user IO. Hi. Yes. English is enormously hard. Okay. So this is lower part of A, this is higher part of A. And then same for B. Low A, low B. High B. So these are the parts of the 32-bit number, presumably. So we're loading register A. So with address 0, so register A will equal to 15. Then we're adding 15 plus, and we're adding address 2. So we're adding 9. And we get 24. And we're storing it into 4. We're loading number from address not 0 but 1. So we're loading 4. And we're equals to... We actually don't have carry because I'm using decimal. I'm very smart. Well, actually, yeah, it's fine. I did a very good example. I used numbers that don't have carry, that don't use carry. Yeah, I picked not good numbers. It's fine, I can just change them. Well, if we assume that we have a 4-bit address, I mean 4-bit number, then we will have carry. Great. So, oh my god, let's account for that, I guess. Do I just mod 2? Bit and I guess. Okay, we get an 8 and carry is 1 now. So okay, we're loading a number from address 1. So this is the high, we're adding the high part. And we're adding it to the number from address 3. We're adding it to 3, so 3 plus 4. 4 plus 3, I mean. 7. And plus carry, which equals to 1, and we get... Heck off. And we're transferring the result into to address 5. So we got 88. Good, so 8 on high part, 8 on low part. 79 plus 57. Complicated halves. I'm gonna just 136. So 136, okay. And it will be 1000 in binary, okay. And will be 88 in hex. So yeah, that is correct. I didn't notice that I'm actually using hex. Like, I accidentally done because I'm using okay, so yes, I didn't notice, but we're apparently using hex. That's Dutch. True, Dutch is superior, yes. I don't read chat. I probably really should read chat more often. The problem is, I cannot make this like on the chat. For me, it's like I cannot lock it in one place. Cool. Yes. Not very cool that I cannot lock the chat, but okay. So yes, apparently we're using hex. Colors, I have, as I said, I have 16 colors. And this is literally hex. Here are those 16 colors. This is from here to here. Those are all the colors. And this is 16. And this is hex. So that's actually neat that we're using hex. And in hex, this is the correct result that we got in this example. So that wasn't actually that bad of an example, after all. 136. Great. I just want to listen to this music, it's amazing. Okay. So that worked. I've performed some kind of maths on 32-bit number, in theory. Actually, we could use literally... well, in this case, we used a register size of 4 bits. It's 4 times smaller. It's fine. Okay, so that's done. What operations we should add? FPU, I forgot about that one. I really forgot about fixed point unit. I don't want to make floating point unit because floating point... I don't know how to add floating point numbers. I could figure it out, but no. I really don't wanna. Like, how do I add... I know it would be very simple to add numbers with the same exponent, but how do I add with different exponents? It's just hard. Floating point numbers are hard. To do in hardware, at least. On paper, they're actually quite simple, but okay. So, now. Fixed point numbers. This is much simpler. They are less accurate, but I mean, we do have operations add at C. So we can just use those to make literally infinitely large fixed point numbers. Or we can just use fixed amount of precision on float, so 8, 8. So the number will go between minus 127, no, minus 128 and plus 127. And the precision will be interesting precision, I don't know. It's to the power of minus to the power of 0 plus 2 to the power of minus 1. Yeah, let me just do very quick maths, because I'm very good at maths. So, the result is 1.992. What the fuck did I even calculate? Yeah, that seems correct. So this is the precision. This is the number that we can get. Somehow it's bigger than 1. It's not supposed to be, right? But yeah, it will be enough. 8 bits of precision. It would be neat to... It would probably break reality. Yes. Oh, and you have... actually, I forgot to make the browser back to its correct size. But you didn't miss anything, so it's fine. That's the correct size. Okay, floating point units. Fixed point units, not floating point. Who uses floating points? It's awful. Okay, so I forgot how to... Well, addition and subtraction for floating points for fixed points is very simple. About multiplication and division, I forgot how to do that. But I have to shift the numbers a bit, I remember. Because I remember you kind of lose precision when you're multiplying two fixed point numbers together. So, yeah. Is it a good idea to make FPU? Floating a fixed point unit? Because, I mean, you can do it with those operations. You can just do integers. I mean, you have add C, you have sub C. Yeah, it will be more trickery to actually do fixed point numbers, but it is possible the computer will be Turing complete. So it will be able to do that. It will be able to do anything computable, actually. So simulation, so the universe simulation in Scrap Mechanic Vanilla will be possible. Accurate universe simulation, of course, is possible. You just have to be very patient and wait till the death of the universe. So, yeah, it's fine. It's not that long. What if you made a super bare bones Turing machine? Bare bones. I know about so very bare bone computer is a computer that has, I think, literally one operation that does literally everything, and you can probably guess how painful it is to write using this. I really don't remember how can you fit literally everything into one operation, but I think there is such operation. And it will be a very bare bone computer. I'm not sure how to make it though. So it was pretty complex instruction, really. With bare bone, I mean really simple. Yeah, one instruction. It's as simple as it gets. Like really, really simple. Really, really simple computer. I mean, the one that it would be simple to code, kind of simple as Brainfuck PC, I guess. Yeah, I do. Turing machine is a machine that has an infinite tape of instructions, and because the theory isn't complex, it's not. A Turing machine is a machine that has an infinite tape and a head. So the head reads the data inside the cell that it's currently pointing to, and it performs some kind of action on it. So it can either set this cell to some number or move left or right. I think that's all the operations. So that's yes, infinite strip, as I said, infinite tape, strip, same thing pretty much. So yeah, I do know what a Turing machine is. I mean, how would I not know about the Turing machine if I'm making freaking CPU in Scrap Mechanic? Like, this is weird to create CPUs without knowing what Turing machine is. What the computable means. Because computable means the stuff that can Turing machine complete. Compute. Yes. So yes. Right. And I mean, I could do a Turing machine. It is possible. Turing machine, I mean, it's very simple. It would be a definitely interesting project. Wouldn't be very useful in my opinion, because it's simply too simple. That's great how I said that. So I mean, every Turing machine. Okay, so let's. So are we doing BLCM or are we doing a Turing machine? I just doesn't really matter. I mean, the instruction set it's pretty much complete. I just have to add some other stuff. I have to figure out Not much else, really. Most part of it is done. For the instruction set, not the computer. Because for the computer I made memory and some of the other... Yes, with 20 ticks per second it would be really slow. Well, we can just... Scrapping Cannon has 40 ticks per second, in which the gate can be 20 times on and off. But yeah. It would be really slow. We can use some very interesting mods, but mods are bad, of course, everyone knows that. Using mods is lame. People who use mods, they're not good. So, as you can see, I don't have any mods installed. Don't pay attention to... oh, I have a bot joined. Hello, bot. Welcome to the stream. It's not nice to meet you. I mean, it's nice to meet you. So as you can see, I don't have any mods. I don't have... Wait. I don't have... Where is the math block? It's vanilla, don't worry. It's all in vanilla, you just don't see it. Yeah, that's weird, but there's no math block. Okay, I guess. So we can make a Turing machine, I guess, right now. Is it an arithmetic block? Where? Maybe it is. Oh, the stream died again, how convenient. But yeah, I don't have actual maths block. I do have other stuffs though. Stream dying again. Yes, I see. It sends me this message that, hey buddy, your stream died. So need smart toilet. That's not very smart. Ammo fill, food fill, empty restricted. Oh. Oh, I see. That's like for battles. Jeez, there's so much stuff. Rotate. Oh. Wait. Oh. But I move it not towards me. Para pa pa para pa 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 para pa pa para pa 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 para para. Oh, R. Pa 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 para pa 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 para. Oh no. Okay. This is just... I don't know what am I doing at this point. What do we do now? I don't know. We have to make connection protocol of some kind. Although I don't know. Do computers really need lognet or spotnet or whatever it's called? Because I don't know. Pointless. You can, and also it's pretty slow. We can just use logic gates like this. We can just connect all computers together with blocks. It's much simpler than using spot guns and aiming them somewhere. I guess it's less flexible, but I mean, you wouldn't be able to place the computer on terrain on not a flat surface. It's just very hard. Because most computers are pretty big. Well, I do have only mine computers here, so... Well, most computers are pretty big. Like this one, it has literally 200... It's like giant. You wouldn't be able to place it if you wanted to. Well, this is an 8-bit version of Quantum. So you will be able to place it everywhere. But yeah, I don't think computer really needs SpotNet. There is no point in it. Then what can we do? So I have to make... I haven't even started on the base. Let's make the base for the computer. I'm gonna use, I guess, concrete as the best block in the game, I guess. I could use plastic, it would be less heavy. But plastic is... We have enough plastic in our real lives, and I don't want to have even more plastic in virtual life. So let's go with concrete. I guess. And so, let's make a panel with the information. And because we have actually, you know what I think we should do? It would be nice to take this whole memory and output each of those cells onto like a screen, because then we'll be able to see the whole memory. I'm not gonna redo the memory, I'm just gonna spend a lot of time in blueprint editor. Yes, I'm gonna try to move all of these XOR gates, self-wired XOR gates, on top, and also I'll have to rotate them. So they would be pointing in the right direction. Does advanced blueprint tool even provide that? Can I rotate them? That's not what I wanted. It's block properties. I need area properties. I can do relative movement. I cannot rotate it because why would I need to rotate it? Shit. Well. Do I have to actually redo the memory? What the hell? No, I don't want to do that. What I could do... What could I do? Because I need to flip all the XOR registers like this, so it would be like a screen. I mean, I can add another layer. I could make a screen and then connect each block individually from here to here. And yeah, connecting 256 logic gates, especially when they're just literally in the middle like this. That's a good idea. I mean, I probably would do that. Just not now. I'll do that after the stream, maybe. I just really don't want to remake this memory because, well, it wouldn't really take long. It's just annoying. I'm tired of making memory in scrap mechanic. That's just too much work. But I'll have like this giant array of logic gates right here. And that will be the memory output. And it will show the whole memory. So I'm gonna use those. I'm gonna do OR gates. Though I don't think it matters, but let's just do OR gates. Maybe I will want to, I don't know, do something. So, okay, let's save that, spawn that. Wire those. Gonna place it again. Gonna wire it up again. And gonna repeat it another time. Guess I could make a time lapse of me just literally wiring all of these up. So that's the amount of logic is that I'll need to connect from memory to here. That would be an interesting task to do. Let's place logic gates right here, and this will be an address pointer. And I'll also grab the data from the from here, from this decoder. Yeah, seems fine. I'll place memory. It doesn't matter where I place it. It's important to not forget that I'm doing dual core, so I'll have to think about how the hell do I do that. You can use the blueprint tool to do that, right? I wish. I just... Not really, I don't think so. I could color like this row and then connect it, because there is no real way to connect it. I guess I could place the memory not horizontally but vertically, so just slap it right here, and then I'll be able to do that with the connect tool very easily. But it just wouldn't look very nice. It would be hard to modify afterwards. So yeah, I will have to probably just do it completely by hand. So connect 256 logic gates by hand. Well, plus 16 for the decoder part. Not gonna do that on the stream again. I'm gonna do that off the stream. You can just connect it in area, so you can just connect per row. Oh, yeah, I guess that's true. I forgot about that. Yeah, the blueprint tool, no, I don't think I can, like, connect in area. I can do offset, but I cannot do, like, in area. And, I mean, it wouldn't make sense to connect it in the area. It wouldn't do any good if I would connect it in the area. It's just impossible. So I'll have to either make the memory just literally slapped and look like a sandwich. I'm pretty sure you can though. Again, I'm checking the advanced connections and there is no area. There is area properties, but the area properties needed to change the... So I'm gonna... Fuck it, I'm gonna share the actual screen. So right now you can see what I see. So yeah, the resolution is the best. I don't know, like this, I guess. So, I don't know if you can really see anything. Yeah, you can. So here we go. Here's the advanced connections. And if I remove this, let me just close everything. Okay. Here's this memory, right? And advanced connections, and that's all the stuff that is in advanced connections. So we can connect logic gate. The offset, this is literal offset for the for when we're connecting. So if I will do, I don't know, something like that. And I will, for example, select those gates. So, for example, actually, I need to paint this a little bit lighter, so I will be able to connect more easily. So, named... Okay, here we go. So here we go. Logic gate, so this is axis X. So we're connecting on X and Y axes. And now let's, for example, connect from this gate. This will be the source. And let's connect to these gates, but I don't want to connect to orange gates. I want to connect to white ones. So for that, I will need to offset on X1. And then if I wired it, 3 connections is made. And this is literal offset for the connection. So we connect from the source block to the orange block, but we're doing an offset of 1, and so we're actually connecting to white one instead. And so with that, we have this. So this is not area property, unfortunately. And it wouldn't make sense if we could manipulate the area, because, for example, we select the area is volume, so it's just like a 3D cube or a 3D rectangle. I don't know how it's called in English. So if we select, for example, this area, this portion of the area, I want to connect this part to this part, top part. Then when I select this part, I select this part on the screen. I mean, and I cannot select this part. Like, it won't fit in the volume of the connections, so it will be simply ignored and no connections will be done. So yeah, nothing will happen. Oh, right, yes. Right. So area properties, we can just modify the position of the block. That's it. And the type of the block, like AND gate, or which type of it. And so yeah, that's it. But you could use the area properties to paint it. Yeah, I will do it to paint it. It's just a lot of pain to really paint it. Because I have to offset the area, but it will be still faster. It will be faster to connect in rows, I will say that. So I guess I can really, what I can do is I can swap this part, this layer of gates and this layer of gates. I can just swap them with literally no harm done, and it will work just fine. Actually, it might look better. Or not. I do like the look of it right now. It looks nice, I guess. So yeah, I can just swap this layer, and actually I'm gonna do that just to see how will it look. Maybe it will look nicer. Do I need to show what am I doing in the advanced blueprint tool? I'm gonna show it. Though it will look quite funky because of my screen resolution. So what I'm gonna do is I'm going to go to area properties. I'm gonna close that, I don't need it. So very weird offsets, I hate that, but it's fine. No, 3. How do we swap them? I guess I can select the... Oh yeah, I can select the bottom layer, the center layer, and I can relative movement. So what coordinate are we going? Z. And we can just move it by 2 blocks on top. Like that, as you can see. And then we can just take all of that and relative movement by -1. And here we go. We swapped the layers. I have saved this as a memory, right? Yep, I saved it, so it's fine. So let's go with named. This one, and yep, here we go. The layers are swapped. And you know what I can do? I can JSON modify this. I could like make a Python script to just change the rotation for this layer. Yeah, that would work. So I can make a Python script that just uploads the blueprint into it, and you can just change the rotation, because in area properties you cannot change the rotation, because rotation is saved as two things, as like axis X and axis Y, I think, and it's not quite sure how it works. Probably very simple, I'm just really didn't think about it. But yeah, it's stored like -1 and 1. No, that's actually incorrect rotation. -1 and 2? No, I don't think there's -1. 1 and 2. Or -2. -1. I'm not sure about. I think this, like, they look like this. There's like this rotation. Oh, I'm still sharing the screen actually. I can show you that. So let's go to blueprints. 2 kilobytes, that's the smallest one. Let's see what's that. So as you can see, here's x-axis and y-axis. Yeah, -1, -2. Actually, that's exactly what I typed. There we go. So that's how the rotation is stored. So that's how the rotation is stored. And I guess I could just access this using, like, change it in using a Python script. It would be simple. Thankful I do know how to use Python at this point. Just a little bit. Let me close all of that. So, yeah, I'm not gonna... then that will be much easier to connect all of that. Actually, right now I can literally connect that all on the stream. One by one. I wish I could show you the weather right now. I guess I can actually turn on the camera. Oh, that would be hilarious. I could show you the snow. It a little bit changed how the stream looks. Just a bit. Also, I haven't actually checked the stream in a bit. Like, I haven't checked how it looks. Maybe it looks awful and I don't know about it. The stream in a bit. Like, I haven't checked how it looks. Maybe it looks awful and I don't know about it. The stream in a bit. Like, I haven't checked how it looks. Maybe it looks awful and I don't know. No, there is not much squares here, so yeah, it's fine. So, do I have some... Right, are we connecting? It looks nice, yes. There is not much squares, so it's nice. The compression is not good, not bad. I could do bitrate of 15,000. No, I couldn't. Never mind. Okay. I'm streaming for 2 hours. Wow, that's nice. That's impressive. Though I did stream 4 hours before. I'm honestly quite a bit surprised that I was able to that I'm streaming for so long today. Doing so much. I'm streamer now. No, I'm not. But it's fine. I wanted to change the music and I wanted to connect those logic gates one by one. Yeah, that seems like a good idea. No, I'm not going to, because I wanted to rotate them. That's what I wanted to do, yes. Rotate them, and wait, am I still gonna... If I rotate those, then I'm essentially doing what I said I could do. Just slap it right here, and make it a literal screen. Just with different kind of axes. What if you did a 1st of April with basically 0 bitrate? What is the minimal bitrate that I can even do? Does it look nice? Nothing changed. Nice. Ah, come on. Nothing changed. Ah, come on. Nothing changed. Ah, come on. Changed the bitrate to 50, but it didn't change. I guess I have to reload the stream because it doesn't want to apply 50 bitrate for some reason. I don't know why. 50 bitrate seems like a good bitrate. It's fine. Yeah, that's a good idea. Just make a stream with 50 bitrate, 50 kilobits per second. So it's even 8 times smaller. Oh, that was... I know that I died again. So, yeah, that's a good idea. I'm gonna do 6 kilobytes per second stream. That will be... That's a good idea. Thank you, Burger Box, for your idea. Like, the stream is fine. You'll... Yeah, I mean... It's fine, come on. And have the audio bitrate shit too. It's just... You're not gonna even understand what am I saying. So yeah, that's a good idea. Do I have anything else from the for the music? I have only cursed music. I could place it, but it's literally it's not a good idea. What that's I'm trying to say. Also, they are all cooperated probably. So that's not a good idea either way. I have this music. Welcome. I don't think I should play it on the stream though. Just the ultimate paint stream. I mean, that's a good idea for a stream, yeah. I mean, sure, it's fine. 50 kilobits per second for the video, and like, I don't know what's the minimum for the audio bitrate, but just make it horrible. Yeah, it's a good idea. And then stream title doing ray tracing in vanilla scrap mechanic. So, yeah. Right. Right. So, that's interesting. Great ideas here. Yes, only good ideas. Great. Good. Yes. By the way, this was supposed... Oh. Here's the hex values for the colors. For those who needs those. For some reason. You can save them. They're not in the order though. So this is just random numbers. I have some weird stuff here. Never mind, I have everything is good. It's the one and only. It's the almighty cube. It has much more blocks than this than it says. Such a casual music when there's like a giant cube. Now that's big, yes. I need to make a 3D printer that will be able to print that. I don't even know how many blocks there is. 16, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's big. It's 208 plus how much? 4, 8, 10. So 218 blocks by 218 blocks by 218 blocks. I have to include that because I was really confused how big it is. I don't remember why did I even need this. Also have this. Is this the smallest one? Yeah, it is the smallest one. This is the one from known game, you know. Why'd I have 5 and I have this one? Oh? Such a casual music and there's fucking... Yeah, I really need to make just a pretty big 3D printer that will be able to print all of that. Talking about 3D printers, maybe we should make 3D printers because computers on the stream is not a good idea. But I like making computers off the stream. What's that? For some reason, watching YouTube while playing a game causes my graphics card to freak out every now and then, and it just gave me a heart attack. Oh no. While playing, freak out. It's fine, you know, it's fine. What are you playing, by the way? Playing Scrap Mechanic? I don't remember if you're in my friend list though. So it doesn't seem like you. There is. A spaceship. Oh, the one from very interesting game. Starting with A and ending at us. Is it the game from that game? So it was very popular at some point. Is it the spaceship from there, like from one of the maps? I hope so. Okay, I guess I'm gonna do a 3D printer. I have no idea what that is, so no. The game starting with A and ending at us. Among Us. Is that the spaceship from there? So ridiculous. Okay. Yeah, I'm gonna make a 3D printer because I'm tired of making a computer. Why didn't I see that? I mean, it was complicated. And also I said that no, it's not that space, not that ship. Ah, that's sad. It'd be interesting to play Amogus in. I can send you a screenshot via Discord though. Yeah, why not? A variant development. Oh, that's a challenge mode. That's interesting. Looks very familiar. I don't know why. I'll have. Yeah. I think blueprint tool. Yes, it does have mirror creation option. So here we go. That's mirrored memory. Oh, neat. I died. Right, so I'm going to make a printer. For how long will I run the stream? I mean, I wanted to make 9-hour stream, so I guess I can have a 5-hour stream. Right now it's 2 hours, so I have to stream for 3 additional hours. Just wasting my day doing streaming. It's a good idea, but not good idea. Okay, let's do a 3D printer, why not? I did want to do it. So, my printer still had some wobbliness. So I have to solve this issue, and I will solve it probably quite easily. I think I do know how to solve that. Also, I'll try to make it as not big as possible. Interesting. That looks nice. Right, so yeah, I'm gonna do a 3D printer again. Because 3D printers are nice, and also I do want to make a nice 3D printer. Because I wanna be the best at everything, literally. I mean, it's great. So, I'll do this thing, I guess. So 16 by 16 by 8? No, 16 by 16 by, I guess, by 16. So I'll have a big cube. Big myself, yes. I guess something like this. That's not what I wanted. So 4, 5. Wait, no, 4. Everything correct. Okay. So 1. Speed is 5, of course. No, speed is 6. 6th speed. It should be less wobbly, so I should be able to push it even further than that. I should be able to push it to maximum, actually. That would be cool. Have it on maximum. So this is going to be very, yes, a printer. So 2, 4, 8. And I'm gonna add a control. So this is X. So I'll connect those like so. And let's check. So it goes up to here. That makes sense. So where the cardboard table should be. I do see a lot of inertia, which I don't like, but it shouldn't be that bad, right? So I could move the table and the head of the printer. Both of those. Because table gets pretty heavy. And having wobbliness in one direction is better than having in both, so I'll do that actually. I'm gonna move the table and the head. The printing head. Also, the printing head will be a little bit more complex. Mostly because I'll have to glitch hole it somehow. And yeah. Something is very interesting happening. Okay. So that's the end. That's correct. Yeah, it's correct. Seems correct. So the head's position should be right here in the middle. Yeah, right here. And then I'll be able to just go like this. I love this music. It's so calm. Okay. So how much blocks do I need? 4. 4. Okay, I need... That's a lot of space that I need. So like this. Okay. I will have it maybe this wide. Yeah, I guess like so. Make it out of concrete, this part. Or completely make it out of the structure block. I guess I'll do it like so. Yeah, that will look nice. And then I'll have to go 16. Actually, will the printing head even reach till this point? Because I don't know what's the maximum range of this thing. So... place one block. It doesn't show for how far it can shoot. Well, let's try 16. Yes, it does reach. Perfect. Let's try then more than 16. Okay. So maximum distance is 16. Okay, so this is one bigger because yes. And then I have to place the printing head. Or wait. I can just move up and down if necessary then. I mean, I'm going with 16 cubed. I don't really need more than that. It would be, yeah, cool, I guess. No, I don't... Yeah, it would be cool to print 16 by 16 by lot, but the problem is it will have the wobbliness in z-axis. I just want... Because right here, the table wobbles in x-axis, it's fine. Previously it was wobbling in 2 directions, so it wasn't really nice. So I want to make it print faster, obviously. So that's why I'm doing that. I'm doing head also move, just in one direction, so I cannot add more distance than that. I hope that makes sense. I mean, I think it does. Okay, 3, then 4. And have I placed it in the correct place? Please tell me that I did. Well, I have to literally place it inside this thing. Oops, I have to actually move it, yeah. A bit to the... a little bit back. Okay, let's just cut it off. Scrap mechanic physics is very nice. Just flew away somehow. Jeez. And it goes gnome. Yes. It goes gnome somewhere else. Just leaves this world. Okay. Like this, and then... done. Looks perfect. So the starting position is now different. That sucks. Well, actually, from this position in the top left corner, as it is in the screens. I guess most screens have this pixel as the top left corner is like 0, 0 coordinate on the most screens, I think. So yeah, going to have this one too. Okay, now I'm going to make those rails so it would be able to slide along. Yeah, I think that's fine. Oh, I almost fell. Okay, so this is 1. 2. On almost maximum speed, then 4. And then 8. Like this. Okay, right, nice. So now I'll do the same thing. I probably should place it at the bottom, so I wouldn't need to go that far away. So did I connect it? Yeah, I think this one is connected to this one. Like that. Perfect. Okay. So let's try this on the... if it overshoots, it probably will. No, it will not. Never mind. And does it actually reach? Yes. So that's great. There we go. That's neat. It works. Somewhat. I want consistency. Here we go. That doesn't look bad. Looks like a actual crane. Neat. Now I somehow need to fit 4 heads, 4 vacuum pumps into one place. For speed. So why do I want to fit 4 vacuum pumps into one place? Well, that's because, yes, speed, as I said, and also because we're going to use a different block for the airspace, because we cannot print an air. It looks industrial. Yeah, it looks industrial. And it looks pretty neat. Like a literal crane. And I guess, you know what I could do? Could do like so. I like how these blocks cast shadows, by the way. You can see through them. But the light, it can't. Oh, okay, it's fine. So it shouldn't affect anything. So if I'll go back, right here, yeah, doesn't affect anything, no harm. And I'll, oh lol, I never noticed that. Yeah, the shadows are very nice. I just really like nitpicking on literally everything. So if there's a small mistake, I'll probably try to notice that. I might not notice that, but I will try to. I don't know if it's good though. Okay, I'm gonna actually have it still here, so that I will be able to place nice. Okay. Fuck it, let's go with build. Let's just do building. Let's go industrial. Why not? Just make structure. Because why not? This is completely useless. But, I mean, it might look cool. So. I mean, it looks like an unfinished house. So, yeah, that's good. Now let's push a lot of heads into each other. Okay. I will use Advanced Blueprint tool because the tools that Fant provides, they don't save much. Let's lose. It is useful because if looks nice equals true, people use creation 3D print. Yeah, that's true. Yeah, you're right. If it looks nice, then people will use this. It's very true. I guess I could fit electronics somewhere so it will have it less like will look even nicer. I do have place right here. There's literally nothing besides just pistons, so I could like make a small pad like this. Probably not out of the same material, but yeah. And then I could place all the electronics right here. Yeah, that would work. Means I need space right here. I might do that. So, okay. Now, I'm gonna place a chest. Like this. And I'm going to place one this. And okay. I guess I'll... Okay. So this will print using... So we'll use what block for the main... For the actual 3D model, not for air. For air we'll use glass or bubble wrap actually. Guess we'll use wood. It's a good block. Yeah, let's use still wood. Oh, and I have to go for now. Okay. Plastic, because real 3D printers use plastic. Yes. Actually, that makes quite a lot of sense. I don't know why didn't I think about this. So I'm gonna include filter plastic. 1. Same here, because for speed. And then I'll use glass for air. And also after I'll set the filters, for a bit, we'll stop the stream, and I'll continue in a few amount of time, because I want to eat, and I'll go eat. I mean, I already have food right here, so yeah. I'll go eat, watch videos, and drink some tea. That's my plans. So for now, thank you for watching, Burger Box, and everyone else who watched, but not said anything. Thank you for watching. I wish you a good day. We will still continue the stream after like I don't know, half an hour, maybe an hour, and bye. Yeah. Yes, that's very true.